Hello, hello, hello. Hope everyone is doing well and all good. So this is now going to be a confidence interval for m sub 1 minus m sub 2. So we're talking about a two sample confidence interval right now. All right, a two sample confidence interval. So we're going from basically what we did before was 10-1, and that was for proportions, right? And now we're going to be going on to confidence interval. Sorry about the lighting situation here, but whatever. That's more important what I'm saying anyway, right? All right, so let's take a look right here, all right, at this particular problem. This is page 197. Page 197 in your workbooks. All right, it shows right here basically what you're doing, all right? We're doing the state plan do conclude right here. Let's just read this real quick. To construct a confidence interval for the difference between two populations or treatments. Treatment means mu sub 1 minus mu sub 2. You should follow the familiar four-step process. We will estimate the difference by comparing the sample means and build an interval around the point estimate by using the standard error of the statistic and a critical t-value. To construct a two-sample t-interval for a difference between two means, state is the parameter of interest and the confidence level you will be using to estimate the difference. Plan, indicate the type of confidence interval you are constructing, and verify the conditions for the random, normal, and independent are satisfied for the two samples. Do the actual construction of the interval using the following formula. We can also use the TI-84 as well. But right here, this is good. This is the formula right here that gives you the sample 1 minus the sample mean 2 plus or minus t star, right? That has according to do with whatever the confidence interval is, t star. All right, times the square root of a sample standard deviation squared over n plus the second sample standard deviation squared over n sub 2. Where t star is the critical value for the t distribution curve having degrees of freedom equals smaller of n minus 1 and n sub 2 minus 1. So basically you take both degrees of freedom, compare them, and you take the smaller of those. Or you can just use technology, right? You use the calculator, gives you the degrees of freedom automatically. Conclude by interpreting the interval in the context of the problem. Okay, so let's take a look right here. Researchers are interested in determining the effectiveness of a new diet for individuals with heart disease. 200 heart disease patients are selected at random and assigned to the new diet or the current diet used in the treatment of heart disease. The 100 patients on the new diet lost an average of 9.3 pounds with a standard deviation of 4.7 pounds. Okay, so right here, the new diet right here, what do we have right here for the new diet? We have n equals 100 patients, so I'm going to call that n of n equals 100. All right, and they lost an average of 9.3 pounds, so I'm going to call it x bar of n equals 9.3. And right here, standard deviation is 4.7. That's a sample standard deviation, so it's be s of n, and this equals 4.7, right? No problem. Now, the 100 patients continue with their current diet. The current prescribed diet lost an average of 7.4 pounds, standard deviation of 4 pounds. No problem. So let's call that, the current one. We're going to say that n sub c equals 100, because that's 100 people. We're going to say right here, the average x bar of c is going to be 7.4. And the standard deviation is 4, so we'll say S. That's a sample, right? S, C equals 4. Okay, that's good just to have that right there. All right, no problem. Let's do it. So we state we want to construct a 95% confidence interval, CI, for m sub n minus m sub c, where m sub n is the true mean weight loss for heart disease patients on the new diet. Remember, n stands for new. M sub c, the true mean weight loss for heart disease patients who continue on the current diet. All right, and right here, of course, right here we have a confidence interval, so we don't need to put the alpha level here for a confidence interval. All right, we're good. Plan. what do we have? We have random, 10%, and in this case, it's normal large sample because we're talking about a mean, right? So random, yes, patients were randomly selected and assigned to each treatment. Okay, you can see that right here. I believe it is right here for this particular one. It is so there's here on the second sentence. All right, it says right here, 200 heart disease patients are selected and randomly assigned to the new diet. Okay, or the current diet. No problem. 10%, okay, we have 100 is less than 10% of all heart patients right here. I'm sorry about that. That keeps on happening. 100 is less than 10% of heart patients for all heart patients, right? Each group is 100, so you didn't have to write it twice. And normal large sample, n equals 100 is greater or equal to 30, n equals 100 greater or equal to 30. They're both greater or equal to 30, so we are good there. So we have a 2-sample t interval for mu. No problem. Let's go to do. Okay, we can go ahead and use our calculator for this. So we're doing a 2-sample t interval. So let's go to stat, tests. Oops, sorry about that, tests. And we're doing a 2-sample t interval. So it's down a little bit. There it is. It's easy to miss, so just be careful with that. And wait, I'm sorry, that's right. We do a 2 proportion t interval. So let's change that. Sorry about that. Let's go back to tests. We want a 2 proportion t interval. Let's see here. There we go. No. We want a t interval, right? Oh, no, I guess that was right. Okay, 2-sample t interval. Okay, I'm sorry, I'm getting confused here. But we have it for, of course, stats. I was just confused by what it looked right there. No, that's good. We were good initially. Forget what I was just saying. All right, so stats right here. So this is why it was really important to write what I first wrote down in the very top, right? And hopefully you jotted that down. So the first sample, the x bar sub n was 9.3, right? So let's put that in. The sample standard deviation was 4.7. And we have n equals 100. Next one we have right here is x bar sub c, right? That was the current diet. That was 7.4. Okay, and we have the sample standard deviation is 4. And we have that n value was also 100. They were both samples of 100. Confidence level was right here 95%. So we're going to say 0.95. And no, always put no right here for pooled data if we're doing it like this. Okay, and repress calculate. All right, there we go. It looks like we have 0.68274 to 3.1173 and a degrees of freedom of 193.06. Okay, so let's put that down right here. So for do, what do we have to put? We put the tech 2-sample t interval, 2-sample t interval, and we have right here the actual interval is 0.68274 up to 3.1173. Okay, with the degrees of freedom, make sure, remember, if we're talking about mean, we always have to mention, and we're doing either a interval or a test, yes, a t-test, we need the degrees of freedom, that is 193.06, okay? And then we're good right there, and I'm going to go back to my whiteboard for the conclusion, so I have plenty of room to write that down, okay? That's from the previous problem, but please ignore that. And actually, let me just erase all this. Okay, so we're going to say right here for conclude. We are 95% confident that the interval from 0.683 to 3.117 captures, so let's start that. We are 95% confident that the interval from 0.683 to 3.117. Captures right here, and what are we capturing? We're capturing a mean, right? So we're going to say right here, the mean of the new minus the mean of the C, which equals the difference. That was a difference, right? Of the true mean weight loss in pounds for the patients on the new diet and the patients on the current diet. All right, and we're good here. What does this mean though? Right here, notice 0 is within this confidence interval, right? So it looks like this confidence interval doesn't really prove anything right here because we have 0 within this confidence interval. So the difference could be 0 right here. Okay, but anyway, we're just doing an interval anyway. We're not doing a test. But if there's a subsequent question, you would have to note that, oh, 0 is actually in this interval. So we're not actually proving that the patients with the new diet lost any more weight than the patients on the current diet. Now we're proving we didn't actually give significant evidence, I should say, instead of the word prove. All right. Anyway, all good. Thank you very much. See ya.